Hello everyone, Sammy here. Welcome back to our Simpy exercise. This is a second video on this particular exercise from HSMA session 2B, where we were building this model of a GP surgery. Now, at the end of the last video, we had reached effectively this point. We had modelled patients arriving at the GP surgery, being registered by a receptionist resource, and then leaving the GP surgery. Now, in this video, we're going to do the remaining steps. We are going to build up to having a second step for these patients. So after they've seen the receptionist, they will be seen by a GP. This GP consult will take a different amount of time to the receptionist consult, and we'll use a different resource, our new GP resource. Next, we will go on and we will build in this sort of branching path after the GP consultation. So we will have 25% of patients going on to book a test, requiring the receptionist again, and that activity also taking its own amount of time. 75% of patients, however, will leave the GP surgery after they are seen. And finally, we will go on to add this extra set of patients coming in via a different route, these patients who are calling. Now, remember, in the exercise brief, we were told that the GP surgery want to look separately at the data for these calls coming in, but this will also use the receptionist resource, but this is only a simple single-step process like we've built so far. Now, it took us quite a long time to build this first bit of the model, but actually what we've done here is set up all the bones of the model, and actually building in these extra steps now will be relatively quick. So I'm going to go through, as I say, one at a time. First, we're going to get the model working with this GP consult step in and nothing else. So we will have the registration, the GP consult, and then they will still leave the surgery. Then we'll do the branching, then we'll do this bit. So we'll have a working model at each step of the way, effectively, so we can see what we are adding in. Now, first thing we need to do is actually go into our G class. So we're going to start here where we set up our patient variables effectively, and we need to add in the additional activity times and the number of GPs that we will have. So I'm actually going to start commenting my G class a little bit as well to keep track a little bit easier, or make it a bit clearer where we should add in these extra parameters when we come back to it. So I'm just going to say this bit is our inter-arrival times. This section here is our activity, can't spell, activity times. This bit here will be our resource numbers, and this will be, let's call it simulation and trial. So what we want now is, we remember we're going to have GPs, so we will want to have the mean, let's call it the mean consult time, so that how long they spend having a consultation with the GP, and we are told that takes around about 8 minutes with the GP, so we'll put that as 8. Also here we will have a number of GPs, and I think we were told that at the moment they have, yeah, 1 receptionist and 2 GPs, so we will do 2 GPs. We don't need to change anything in the simulation and trial parameters, that remains consistent. So we can move on next to our patient class. Now here we had the queue time for the receptionist, so this time we'll just want to add in an additional parameter, that is the queue time for GP. Nice and simple. I'm going to comment this up as well, so queue time, so we can just remember that this is just if we're storing the queuing time, because later on we might actually want to store the length of time that each patient is also spending at each of those steps. So, or we might want to record something like their total queue time. But for now, it's it's actually just nice to keep these two queue times together. Now, so that's all we need to do to our first two classes. On to the model class. So we don't need to change any of this. We still create our environment. We still record our run numbers. So remember, when we do trials, we'll have run 1 of the model, which is almost 1 day of, in the life of the model. Run 2 of the model, run 3 of the model. That's just what we're recording here. Patient counter still starts at 0. This time we need to also create our GP resource. So I'm going to do self.gp equals simpy.resource, and I'm just going to mirror exactly what I did above. So simpy resource, our resource needs to live in our environment, our Simpy environment that we created up here, and the capacity will be global number of GPs. So our G class, and we've just created, as you remember, the number of GPs in this class, in this model. So what we next need to do is our patient level results, and all we need to do is copy this line, and this time we're going to have the queue time for the GP. We're going to also want to store the average time for the run. So let's do mean queue time GP run is equal to 0 when we start out. And then we don't need to change our generator of patient arrivals. That will still remain exactly the same. The patients turn up, we create a patient object, which will now include this sort of placeholder for the queue time they've spent with the GP, where we will record that in a minute. We will then have them start the attend clinic process, which we define in the next little bit of code. We then wait until we sample how long it will be until the next patient arrives, and we wait that amount of time, and then we go back up and generate a new patient. So all of this remains unchanged. It doesn't matter that the GP section is happening next. Now, onto this attend clinic method. Now, what I've got open on the right here is the second Simpy example from our Simpy session. And if I scroll down a little bit, you can see this one's got a lot more comments in it, but effectively this one is a two-step process. So this was modelling a system where we had a receptionist step followed by a nurse step. And if we just look at the structure of it here, what they do is they start queuing for the receptionist, and then this block of code is where they are using the receptionist resource. So they're effectively waiting until a receptionist becomes available. We then record how long they queued for the receptionist. Then we see how long they're going to spend with the receptionist. Again, remember this is randomly sampled, but sort of based around how long on average people spend with the receptionist, but it can be a little bit more, a little bit less, or actually quite a lot more or quite a lot less, depending on exactly where we end up picking from the distribution. Then we are recording how long they spent queuing with the receptionist, and in this particular model we also recorded the time spent with the receptionist. We're not doing that here because we've been told in our brief that that's not something that the GP surgery are interested in at the moment. And then finally, what happens at this point is we basically pause the model for that patient until we basically don't do anything else until the activity has finished. And at that point, we will then start them queuing for the nurse. Now in our model, that will be starting them queuing for the GP instead. And then we have a very, very similar set of steps. So actually this time they wait until a nurse is required, we'll be waiting until a GP is required, and everything then is effectively just the same. So let's do that in our model over here. So we'll mirror what we've got here. I'm going to write it out rather than copying and pasting, just because it makes it a little bit less risky that I'm going to forget to change something. So with self.gp.request as rec. So we can reuse this naming convention. That's absolutely fine. We don't have to have them called two different things. See here, we used yield rec. We use yield rec. We've defined what rec is here, and it's just shorthand for request, effectively. Now remember, we created our GP resource, so that's what we're referring back to here. So we're saying please wait, or please request a GP resource. Now, please wait until the GP resource is available. That's what this yield rec line is doing. And actually, I missed a step here. We also need to record when they started queuing for the GP, which is just going to be self.env.now. That basically just means please look at what time it is in our little simulated world right now and make a note of that. We're going to then, after they've waited for a GP to become available, we can then check what time that was. So we're going to say end queue GP is again, what time is it now? So remember, we've waited until the GP was available, so this will be a different time to this, unless a GP was immediately available, in which case there will be no gap. But usually there will be, probably. It depends a little bit on how well this system is actually flowing. So what we're going to do now is we are going to calculate or store patient queue time GP. Remember, we made in our patient object this little placeholder where we're going to store how long this individual patient queued for the GP. And that is going to be the end time so when they finish queuing for the GP, let's say that's minute 180, and let's say they started queuing for the GP at minute 170, so that'd be 180 minus 170, and that gives us a queue time of 10 minutes, hypothetically. Now we want to record next how long they will spend with the GP. So instead of time with the receptionist, we've got time with GP. We're going to do the same thing again. Remember our random x-bivariate, we're sampling from an exponential distribution, and all we need to do is 1.0 over the average time for that GP consult, and that will give us the right sort of average, the right sort of sampled activity time. Next, we just need to put this data about the queue time into our data frame. And actually, to be honest, it might make more sense to do this after we've recorded the queue time. We don't really need to be sampling the time they're going to spend with the GP first, but we'll just follow what we did before. For now, we can always come back and tidy up the order of our code a little bit later just to make it more readable. And we called this queue time GP, I think. So remember, this has to match whatever we called it in our results data frame. So queue time GP. And did I, well, you did call it just Q rather than QEUE. So this will be our patient Q time GP attribute. And then finally, we will wait until that patient has finished seeing the GP. So time with GP, that's all done. Now here, again, remember we're just matching exactly what we did with our receptionist. We're going to have the mean queue time in the GP run, which is just going to be, and I will copy and paste this time. I'm just going to make this a little bit narrower so we can see everything all at once. So self results data frame, and we're going to have queue time GP, and we're going to say please calculate the average time that they queued with GP. We're then going to have a look at the run method, and there's nothing we need to change here. So all we're doing is generating the patient arrivals. Remember that didn't change. We're running until the simulation, until the length of time we said we want to run the simulation for, which we defined in our G class, the number of minutes in this case we want the simulation to run for, but it's a sort of arbitrary time unit. We're interpreting it as minutes for the purpose of our simulation. We're going to then calculate the run results. So that's this method where we've updated to include the whole queue time GP column. And then we will print that those outputs effectively. Now, looking at the trial class, we will need to add in, again, a column where across all of our, so we're going to be recording for every run of the model. So if we run the model 100 times to simulate 100 slightly different days in this GP surgery, we want to be recording for each of those runs what the average queue time is. So this time I'm going to call it mean queue time GP. At this point, remember, we're setting up in our init method the DF trial results data frame. We are defining at this point what we're going to call these columns. We have control at this point. It's later on we need to make sure that we are matching these column names. In the print trial results method, that is just going to print this data frame we've created, so we don't need to change that. However, I am going to add a line in that just does this mean queue time GP and gives us the average across all of the runs. So this is just all I need to change here is say actually this time it's the average GP queue time across all of the runs, and here is we're referring to this mean queue time GP column from up here. Now just a reminder as well here, because we're using an F string, I've got double quotes at the start and end. I've got single quotes when I refer to the mean queue time GP column. That's because if I did double quotes for both, this set of double quotes would match up with a double quote here and it would really confuse Python. So just double quotes on the outside, or speech marks effectively, and then single quotes or apostrophes here. Finally, we have got the method where we run the trial. And all we need to do in this bit is effectively record the mean queue time for our GP as we run each run of the model. So inside this for loop, this is basically saying for the first hypothetical day in our model, we will run the model, we will generate a new sort of simulation based on all the code up until now. We will run that model and we will record the results from that run, that one day in the life. And then we will do this for however many number of runs we've specified. So we've said it 100 times. So what we need to do now is df trial results, and this at method, or this this at just means kind of it allows us to access a particular point in our data frame. So we're going to say for this particular run, in the mean queue time GP. So remember, we set up that column here. So this is where we need to match that column name. And we're going to do my underscore model mean queue time GP run. So just to remind ourselves, see, that's when we calculated the run results for that particular model, we made this attribute, or we set this attribute called mean queue time GP run, which we had created with a placeholder all the way back up here in our init method for our model. So that, I believe, should be everything. So let's run this section, this cell, where we've defined all of our methods. And now I'm going to run a trial. So again, remember the trial has 100 runs. To be honest, I'm just going to change it to 1 run for now, actually, just so we can see a little bit easier what's going on. And then we'll run it up to 100 in a minute. Oh, and I've forgotten, I've closed and reopened this since we last did the last video, so I actually just need to make sure I have imported my packages from this cell. So I'm just going to run this again just for good measure. This class where this cell where we created all our classes, and now I'm going to run the trial. So this is, we've got one single run here, effectively run number 0. We've got the first 5 rows of our patient data frame, and we've got the last 5 rows of our patient data frame. Now you can see here that actually we've got a load of zeros, and that is because there was no queue at the beginning for the GP. This was actually flowing through absolutely fine. When you get to the end here, we've got NaN. Now NaN stands for not a number, and all it means in the context of our model is that these patients never actually finished their queuing for the GP. They may have got into the queue, but they never actually got to the point of seeing a GP and then therefore recording how long they had queued. We could maybe do something special in our model at the end so that everyone who's still queuing, either we maybe record how long they queued up until the end, but actually it's quite helpful to have this not a number, because then you can quite easily go, well, okay, maybe I'll just look at the number of people who queued up until, we can exclude the nans easily, so we're only kind of looking at the averages for the people who queued and actually finished queuing. But it's also just important to be able to see how many people got stuck in a bottleneck, effectively, actually how many people were still queuing for the GP at the end. If that was 10, 15, 20, then we've probably got a real problem in our system. But that will of course be quite situational depending on the model. So in this case you can see we've got a very short queue for the receptionist, but actually the meantime people are then queuing to see a GP is quite long, average of 32 minutes in this particular run. And at the moment, of course, we've only done 1 run, so these averages, these across run averages, will be the same. Now, just while I'm here, I'm going to just tidy up my printouts of the average time. So we're going to do a colon here and a dot to F. Now that just means please round this number here, our mean average, to 2 decimal places. I'm going to do this up here as well, and we will see that. So it's dot colon dot to F, 2 decimal places. This would be 1 decimal place, this would be 3, this would be no decimal places, and so 2 decimal places for now. I'm going to go back up this time, I'm going to change the number of runs to 100, and I'm going to rerun this class. Don't have to rerun this one this time because I've already imported the relevant libraries, and I only need to do that once per session. And now I'm going to run this again. And this time you can see we've got a lot more data frames coming up. If I put this to a scrollable element in my VS Code notebook, you can see that actually I've got run number 1, 2, 3, and actually we've just got this little subset of the patients in each case. Remember, we'll have a different number of patients in a lot of runs, so this time, just because of the variation in the inter-arrival time, we had 173 patients. Here we only had 156. And if I go all the way to the very bottom here, we will see the results, our trial results. So the first 5 runs, we can see how long on average people queued for a receptionist and how long they queued on average for GP. You can see there's quite a lot of variation across our runs in how long they queued for the GP. But on average, people queued around about 4 minutes for the GP and about 61 minutes for a 4 minutes for a receptionist, and about 62 minutes for a GP. So that is effectively this model now done. So now we're going to go through and we are going to do this branching section. So in this branching section, I'm going to open up Simpy example 3 over here instead of Simpy example 2, because that's where we've got a nice branching example. And I'm just going to save this, and then let's have a look at the branching example over here. So in this particular model, we'll probably be wanting to record how long people then queue to book a test if they are booking a test. We are also going to look at so we've got generated patient arrivals, attend clinic. So the attend clinic method is the one that's going to change the most. So in this particular model, it's not the one we're doing, it's another example. They've got a receptionist step just like ours. They then have a nurse step. You can see this time they've got a nurse, something going on. Now, in this model, there is a chance that they will see a doctor. Ours will be a chance of booking a test. But all we do is we sample from a random uniform distribution. Now this is a distribution where in this case we'll get a number back between 0 and 1. And in this we've got an equal chance effectively of getting any number between 0 and 1. It's a little bit more complex than that because we don't specify the number of decimal places, but actually if you looked at the chance of getting a number between 0 and 0.1, the chance of getting a number between 0.11 and 0.2, and so on like that, you would find that across time across many repetitions, you've got an equal chance of getting a number between each of those bins, effectively those kind of categories of numbers where we've sort of aggregated them together. Now, all this effectively means is that if you have a probability of something, so in this case, probability of seeing a doctor, in our case, we know that we've got a probability of needing a test. When you sample from the random uniform distribution, if the number you sample is below your probability threshold of that activity happening, then you can just run the code for that activity happening. If the number that is sampled is greater than the probability of that activity happening, then we don't run this code. And what this means, over hundreds of runs, over hundreds of instances, we will get about 25% in our case of patients. I think is it 25% who 25% will need to book a test, and about 75% of patients will leave the GP surgery. But like with all our other steps where we've had the sort of roughly around the average time people queue, not the average time people queue, the average time people take between people turning up, the average time it takes for a consultation. Remember, we've had slight variation in each case because we are randomly sampling, but around a sort of a theoretical, from a distribution that mirrors reality, it mirrors the variation that you will see in real life. And here it's just the same. So sometimes you'll run the model and you might find 30% of people book a test. Sometimes you'll run it and it might only be about 15%. Probably won't be all that far out of those ranges, but just be aware that you will get slight differences, and that is going to reflect reality. You're not going to have exactly 25% of patients every day booking a test just because you have different people coming in, different needs, etc. So what do we need to do here? Well, we don't need to add in, we do need to add in how long it takes to, let's say, the test book time. So how long does it take to book a test? I'm going to make this a little bit narrower again. So how long does it take to book a test? We've got it. About a quarter of patients need to book a test at reception after they've seen the GP, and this takes around 4 minutes. So the average time to book a test takes about 4 minutes. We are using the same receptionist resource, so we don't need to do anything there. We don't need to change our sim duration or our number of runs. We are now going to add in the queue time for the booking test, which we're going to initialize as 0. We don't, again, remember, we don't need to create any more resources. We're still using the same receptionist, but we will want to create a column to store the queue time for test booking. And we're also going to want to store the average time across the run for booking a test. Now, our patient arrival generation remains completely unchanged. When we then attend the clinic, so this is our receptionist step, this is our GP step, and this time we are going to check whether people are going to need to actually book a test. And of course, we forgot here one thing. I'm going to create a new section for activity probabilities, and we need to record that the probability of having a test is 25%. So prob test booking required equals 0.25. So now we can go back and use that probability. So here we're going to do like in this code on the right, and this is a very repeatable, reusable sort of coding snippet that you will find yourself using very often. So 0 and 1. So if the number we sample, which is a number between 0 and 1, is less than the chance of needing to book a test, then run the test booking logic. So about 25% of the time the number will be less than the probability of booking a test, and therefore we want to actually run the test booking scenario. If the number is greater, so 75% of the time roughly, the number that we generate will be greater than the probability of booking the test, and therefore we won't run this little bit of code. So that's how we end up with our 25% people roughly going through this process and about 75% of people not going through the process. So I'm going to indent in here, and I'm going to then do, this is where I'm going to record my start queue for the test booking. And remember this, we're not using self here, we're just temporarily storing this variable just for the calculation of the queuing time. So the total length of time that someone queued, rather than we're not recording all the start and end times on our patient object. So again, self.end.now, what time is it when they started queuing? And again, this time with self receptionist.request as rec, so exactly like when they used the receptionist the first time to actually register, we're just going to use the same pool of receptionists again. We're going to yield rec, so wait until a receptionist is available, and then we're going to record the end queue time for test booking, which is self.end.now. So what time is it now? And then we're going to record the patient queue time for booking a test. So on the patient, against the patient object, we're going to store how long that patient queued for the test, and that is going to be end queue time test book minus start queue time test book. So just like before, it's almost identical code. All that we're changing is the names of the parameters and what resource we are using. This time we're going to copy this bit just to put this into our data frame. So we're recording how long they queued for test. What did I call this one? Need to check this. So queue time test booking, I called this. Remember, we create in our init method our results data frame, and we define what the column is going to be called and set a placeholder value for the first instance, and we are going to record queue time test booking, and that's going to be queue time book test. Now I've done something in a slightly different order here. I've realised I missed a step. I need to record how long it's going to be to actually be get this test booked in. So once again, time to book test. How long is that going to take? It's going to be once again random x bivariate 1.0 divided by g, and it's the mean test booking time. And we are then going to wait however long it is to have the self.end.timeout time to book test. So if we might sample this patient took 5 minutes to book the test, and we'll wait 5 minutes before, well, effectively in this case, we've reached the end of our patient journey. They'll leave the system at this point. Now, the other thing to note here is you can see that we've got another level of indentation compared to the code above. That's because we've got this if statement. So everything within here will only run with the if statement, if the if statement happens, and then everything within here will happen whilst holding on to a receptionist resource. While using a receptionist resource, we hog the resource, and then when we get to the end of this bit of code, we give the receptionist back to the pool of receptionists so they can carry on doing other receptionist duties, whether that's receiving those calls, whether it's booking people in, or whether it's booking in tests. We're using, as I say, the same pool for everything. So what do we need to do next? Calculate run results. Again, very repetitive. Mean queue time test book for the run is going to be, we're going to look at our results data frame, we're going to look at the queue time for the test booking and calculate the average. We don't then need to change anything here. This is going to be just the same, but we do need to do df trial results. And again, this is where we're specifying the column name for this DF trial results data frame. So these are the results across all of our model runs. And we're going to call this mean queue time book test. We're going to make that same placeholder. So 0.0 will just be our placeholder value until we actually have some results. And I'm just going to copy this bit so that we can print out on average mean typing in the wrong place there. Test booking queue time across the runs, and that will be mean queue time test. I'm being very naughty here, and I am not splitting this over multiple lines. I shouldn't really be going past this line here, but I will not be dealing with that for now. Finally, the last thing we need to do to make this step work is to go to the DF file results, and we are going to again just mirror this run. This is just going for this run in the, for run 1, run 2, run 3. Please record the, what have I done here? I've opened that by accident. There we go. Mean queue time, and we called it what? Mean queue time book test. So please record for this particular run 1, 2, 3, etc. what the model, in our model, what was the mean queue time for booking a test in this run. Remember, this is something we created in our model up here. We set a placeholder for how long on average it would take to book the queue time for booking in a run, and then when we calculated the run results, we stored the actual results into that attribute, and now we are accessing it from the model. So here we're creating a new instance of the model each time we go through this loop, and then we're accessing that attribute for that particular run of the model. So let's execute this cell, and let's see if we've managed to actually make all the changes we needed to. So I'm going to run this, and so far that's looking promising. And what you can see here is in run number 0, we had some patients. So this patient didn't wait any time for booking a test. This patient has NaN, again, not a number. Why do these ones have NaN? It's not like they would have queued indefinitely like these patients potentially at the bottom. Remember when we were looking at the GP queuing time and we were thinking, well, actually, probably some of these people are waiting an awfully long time, or actually still sitting in the queue at the end of when they have been when the simulation stops running, or they might actually be seeing the receptionist at the time at the point it runs out. So they've finished queuing for the receptionist, but they haven't actually finished being seen by the receptionist. So there's a couple of reasons we might have NaN there. Now, for the test bookings, though, we sometimes have NaN because there's no time to record. These patients didn't need to book a test. They were part of that 75% of patients who didn't book the test in that run. So what you can also see, if I put this as a scrollable element and scroll all the way to the bottom, again, it's not the prettiest. You can see it's splitting here now. It's getting a little bit confusing. Splitting across 2 lines, our trial results data frame. So we've got the mean queue time for the receptionist and the mean queue time for the GP. And if we read across here, we've got the means for run number 0. And here we've got run number 0, the mean queue time for booking a test. And finally, we've got our average test booking time across queue time across the runs. So it looks like we have done everything we need to for this step. So now we are up to this point. We have registered, we've got the GP consult, and we've got this optional step where patients may use a receptionist resource to book the test. Final thing we need to do now is have this step where we call the GP surgery. So we've got a separate pool of people calling the GP surgery. The receptionist, so we're still using the same resource, they'll be answering the calls, and then here it's just a simple single step process. They will leave at that point when the call ends. They don't do anything else. So let's go back up to the start again, and this time we don't actually have a Simpy example file giving us how we can do this, an oversight of how we can do this. So we're just going to close this. We've got a little bit more space to see what we're doing. We've got to work this one out ourselves. So first thing I'm going to go through and do is actually just add these extra times into our G class. So we know that the receptionist answer incoming calls. These calls come in around every 10 minutes and they last around 4 minutes. And there was something else as well that I wanted to draw attention to. And yeah, in terms of output, surgery is only interested in queuing times for each of the queues in the systems, but they would like to look at the results for patients and callers separately. So what I'm going to do is I'm going to start off by recording the caller IAT. So where I have this little section for recording inter-arrival times, the caller inter-arrival time is going to be separate. So rather than trying to do something quite complicated like have a patient come in, sample whether we think they are going to be a caller or a in-person patient, that would get really complicated to make sure we actually hit the right inter-arrival times. So what we're effectively going to do a little bit later in the code is we're going to start up a second process. So we're going to have the callers coming in completely separate, the callers being generated completely separately from our patients, our in-person patients. That's much easier to make sure that we are matching the expected inter-arrival time for these completely two separate sort of groups of patients. And you might find something similar in a emergency department model, for example. You might want to say that high priority patients or more ill patients turn up on average every half an hour, and your less ill patients turn up every 5 minutes, for example. Or you might want to sample on average, you might know that people turn up on average every 10 minutes, and then you might want to sample to say, well, some of these patients are going to be high priority and they're going to go down this pathway, and some of these patients are going to be lower priority and they're going to go down this pathway. So it depends a little bit on what your system is set up like, and yeah, whether you're interested in what way round you're interested in modelling it. So either can be the correct way of doing it. You will develop some intuition from it, which you might want to do. So what have we got here? We've got our mean activity time. So we know this time that mean call time is not 10 minutes. I don't believe it was 10 minutes. Every 10 minutes they were turning up, and the calls take about 4 minutes, like our mean test booking time. They take about 4 minutes. No extra resources. We're still using the same receptionists. Don't need to add any other probabilities, and we don't need to change the sim duration. Now this time we are going to create a new class. So I'm just going to copy and paste this. I'm going to generate the caller class. We're going to still have an ID, we're going to pass an ID into them, but this time all we're going to have is the queue time for call. And that'll be, to begin with, 0 minutes. Now, no new resources to create, nothing to change here. But what we are going to do is, are we going to create a caller counter? I think we will. Let me just have a think about that. Yeah, I think we're going to want a second counter here so that we can count the callers in. So that caller counter will start that at 0 as well. No resources to create, but we will want a second data frame. So remember we were saying we were talking about recording these results separately. And the other thing to note is effectively because we've started the caller counter up here at 0, we will have caller 0 and patient 0. If we just added these results into our results data frame, then we would find ourselves with a rather difficult situation where we have patient zero. Patient zero might turn up first, be seen by the GP, etc. Caller zero, if we put it in the same data frame and set that as the sort of patient ID column, well, they would overwrite patient zero. So actually, our data frame would just be missing a load of people. A load of people would be overwriting other people, depending on what order they turned up. It would be absolute chaos. The other way we could do it potentially is actually we could have something like the caller counter or the caller ID that we put in might maybe have a prefix, depending, if it's a caller, maybe we'll have, C0, and if it's a patient, then we'll have P0 or something. So we can differentiate that way. Then we could put them all in the same results data frame. Again, this might not be the most efficient, especially from a storage perspective when we get up to very large simulation runs, because you'll have three columns for that patient: the queue time with the receptionist, the queue time for the GP, and the queue time for the test booking, which will always be blank because they won't go through any of those processes. The only thing they will be doing is this queuing time for their call to be answered, and therefore it's just not the most efficient use of memory within pandas, within our pandas data frame, because there's so much blank in there. So it's probably just a little bit neater to have a caller data frame, PD data frame, and then we're going to have self dot caller df, and I'm going to call this, so we're going to have patient ID just like before, but actually I'm going to call this caller ID just to make it a little bit clearer. And we are going to have, very similar to this, ooh, results. So we just need to make sure this is caller df, copying and pasting that, and we're going to make this this column is queue time for call answer. And finally, we're just going to make sure that we set the index to be the caller ID. So if you cast your mind all the way back to the first video where I showed you a little bit what that means, it means that rather than having 0, 1, 2, 3, 4 down the side of our column of our data frame as our row numbers, and then a patient ID column, the patient ID, or in this case caller ID column, will be the index. So it will say patient 1, 2, 3, 4, 5, and we haven't got an extra set of row numbers to confuse things. It's just a bit neater in this case. So we're then going to want to store the mean times to run. And again, we still want to record the self mean queue time for call answering within the run, which will initialize as 0. Now this time we need another generator. So I'm going to generate. Just need to make sure that when we copy and paste, the indentation doesn't get messed up. So you can see I copied there, I pasted there, and this def is too far indented. It needs to be at the same level as our other generator. So generator, we're going to call it caller arrivals. This time we're going to refer to our caller counter. So we're going to generate a new arrival. We're going to iterate the caller counter by 1, and then we're going to create a caller. I'm going to call these C just for difference. And actually, I realised I called that the ID, I called the parameter we're passing in the PID. Let's just change that to the CID. Again, just for clarity, it would actually work exactly the same if we didn't change it there. But just to clarify, we're passing in a caller ID and we'll be making a new caller object. So caller, we're going to pass in the CID and the caller counter. Then we are going to do self-end process, and we are going to do make call. We haven't defined that yet. We're going to do that in a minute. And we are going to pass in our caller object to it, like we do here where we've got attend clinic and we pass in our patient. We're going to pass in our caller so that we can write things back to that caller object and so on. We're then going to see time until next caller, and that's a random X bivariate, and this time instead of our patient into arrival time, we will use our caller into arrival time. Finally, we're going to have the self-end timeout, time until next caller. And now we are generating new patients. These won't actually turn up in our model until we do another step, but that we will get to that in a moment. But just bear in mind that if we just ran it now, we still wouldn't have these callers arriving, even though we've created this new method, because we haven't called it anywhere yet. We haven't made use of it within our code. But next thing, so we've got our attend clinic method. So remember, this is quite, it's got quite long now, but we're now going to have a def. And what did we call it? We called it make call. So we're going to have def make call, and we are going to have, I'm going to actually move it up here just because I think it will make our lives a little bit easier. There'll be a bit less scrolling involved. Doesn't really matter which order you put them in, because actually this is just where we're defining the functions. Later on in our model, run method is the order in which we call the functions, in which we actually make them happen. So don't worry about the order you put them in here, just order them however it makes sense to you. So we're going to have self caller this time. We're going to be passing in a caller object. We're going to do the start queue time for call, which good old self.env.now. We're referring back to the environment that is part of this model class, which we can access because we've got self. We're then going to have with, well, almost identical actually. So let's copy and paste this bit, make our lives a bit easier. Just again, pay attention to the indentation when you copy and paste. This needs to be level with the point at which we started the queue time for the call. So we're going to ask for a receptionist, because remember we're using that same receptionist again. We're going to wait until a receptionist is available. We are going to end the queue for the call. That's going to be self.env.now again. And this time, remember we passed in caller, a caller object, and we want to record the queue time for the call answering. What did we call that in this case? In our caller object, that's what we need to refer to. So it's the queue time for the call. There we go, I was nearly there. So it's going to be end queue call. We're going to refer to this time that we just created, and the start time for the call, for the queuing for the call. And queue time call. I haven't been very consistent here, so we're going to actually just get rid of time there. Doesn't really matter what we do as long as we make it consistent among this section. So next, time with receptionist. So actually, let's call this time on call. We're going to sample again our exponential variation, exponential distribution, and we're going to use mean call time. So that's going to give us a sampled call time, how long they are spending on the phone with the receptionist. It's going to be somewhere around 4 minutes, because that's what we told it to be, but it will be varied around that. Let's do caller ID. So that's what we're referring to here. We want to put it in our data frame. We want to use the caller ID as the index row, and then we are going to have queue time. And what did we call this? Let's go back to our data from here. Queue time call answering. And this will be caller, queue time receptionist. So just make sure throughout you're being nice and consistent about your use of caller. And finally, we're going to have timeout for how the time on call. So next, that's everything we need to do with the make call method. They just need to call a receptionist. They need to wait until a receptionist is available. We're going to record how long they queued for. We're going to see how long they spent on the call. We're going to record that in our data frame, and then we're going to wait until the call has finished happening, and then we will give the receptionist back to the pool of receptionists so they can go on and do something else. So the attend clinic method, we don't need to touch that because these patients don't go anywhere near that method. That remains completely unchanged. I'm just going to get rid of a bit of extra blank space there. However, we do need to record the, so what would it be? Self, mean, queue time, call answering for the run, which remember we set a placeholder of 0. Well, this time we need to look in our self dot caller data frame, not results data frame, and we're going to record the queue time, and what did we call this? queue time test test booking call answering. And I've spotted something important here as well. I didn't change that to caller data frame. That's very crucial, that otherwise I'll be trying to put it inside the wrong data frame and it will be trying to refer to a column that doesn't exist in that data frame. So I've fixed that now inside our make call method. I'm making sure that I'm referring to this new caller data frame that we created here. So you can see how easy it is to forget to change something as you start adding in these extra bits. So just if something's not working, go back through with a fine-tooth comb and just make sure you are referring to the right data frames, to the right attribute names, to the right resources. It's really easy to miss one. Where were we next? So we were calculating the run results, and this is the queue time call answering, and we want to calculate the average. Finally, this is the next crucial step. We need to add in a second generator process. So we're going to have self end of process, and this time before this line here is generating our patient arrivals, this one is going to generate our caller arrivals. And remember, when people come into our caller process, so we have, where is it here, generate caller arrivals, we'll be generating these caller objects, and we will be running the make call process within this generator of caller arrivals. So we just need to make sure that we are getting these arrivals to turn up effectively. So that is inside our run method. So now you can see we've got these two separate lines. We've got patient arrivals and our caller arrivals. Doesn't matter which way around you put these, they'll all both just sort of initialize at time 0 of our simulation, and they will start spitting out patients and putting them through those processes that we've defined. Calculate run results, we've fixed that up there, so we don't need to do anything else, and we will now just want to make sure we print our self.caller df2 so we can see what's in there. Finally, our trial method. So the only thing we need to do here, and actually we can put our trial results, so we don't need a second data frame here because all we need to record is self.df trial results, and we will put the mean queue time for answering. We're going to make that 0.0 to start off with. That doesn't need to change. We are going to also record or print even the average time to answer a call is going to be self-DF trial results. That's going to be this one here. So we're going to take the average of this column. And finally, this is where it will be slightly different. In our run trial method, so where we're creating a model for run 1, run 2, etc., running the model and recording the results from that run, we need to put into the trial results for that run. So it's still going to be the same here, run, and we just want to be recording the mean queue time for call answering. But this time, oh, actually, no, I'm talking nonsense here. We recorded in our model already. I was thinking we were going to have to refer back to the caller DF rather than the results data frame. That doesn't happen here because we recorded an attribute that was the mean queue time for the call answering across the run. So that's nice and easy, actually. Same again. So we're going to print the results at the end of that, and let's now execute this cell. So we update all of the classes, and let's try running another trial and see if it works. Now we've got an error. Why have we got an error? Caller object has no attribute queue time receptionist, and that's because we tried to set the caller data frame, caller ID, queue time answering. Oh, and that's because we tried to set it as the queue time. So this is telling us that the error is in line 107. If I click on here, it will jump me up to that actually. So, and I don't have any line numbers here actually, which is part of the one of the downsides of Jupyter Notebook in IPyNote in VS Code. I think you can turn them on, and I absolutely should. But effectively, what's happened here? So I recorded the queue time for the call, and then instead of, when I then went to try and record this in my caller data frame, I forgot to update this to point at that attribute, the queue time call. Queue time receptionist doesn't exist for the caller, only queue time call does. So, as I said, very easy to forget to change something, and it can lead, if it doesn't lead to an error, it's very easy for it to lead to kind of completely nonsense results in your model. So you do have to be really careful with this stuff and try and get someone else to review your code as well if possible. And also there's various other ways that you can test that the model is working as expected, but that's a bit beyond the scope of today. So let's execute the cell. Now it's running this time. And what you can see is in run number run number 0, for example, you can see that we've got this patient data frame here, and then we've got this caller data frame as well, where we've just got a column for the queue time for the call to be answered. You can see it's taking now on average, now we've added in more and more of these processes. People are waiting to see the receptionist for 58 minutes. They're waiting to book the queue time for 57 minutes. They book their tests, those that optionally need to book a test, and also having this average time to answer a call. If I make this a scrollable element and scroll all the way to the bottom, then you can see that in our trial data frame, so we've got trial results here, now we've got 4 columns: mean queue time for receptionist, GP, booking test, and this new call answering column. So you can see sometimes it's been even longer. We've had a particularly busy day, for example, so we've got 94 minutes there where they've had to queue for someone to have their call answered. Some days only 28 minutes. So that is effectively everything we needed to build in the model. We have now got to this point where we have got these GP surgery calls coming in as well and being handled by our receptionist. We've got all of this process for the patients arriving. And let's just try one thing before we finish. So I think at this point you want to go away and try out different things. What happens if you change things, if you make what happens if it only takes 3 minutes to book a test? What happens if the GP is the person booking the test instead? What happens if we are able to employ an extra receptionist or GP or so on? What makes the most difference? So you might find yourself wanting to record in your own little table somewhere what these results were so that you can refer back to them and what parameters you had in place at the time. The other thing I've just noticed is I was meant to be reporting these averages here to 1 decimal place according to the brief, so we'll just update that as well. Oop. There we go, 1 decimal place, rerun that. And actually, so let's just remember in our heads that it was taking roughly 50 minutes for all the receptionist steps and about 30 minutes for the doctor steps, so the doctor waits. What happens if we go up to our G class and we change this to 2 receptionists? And run this down here again. So what we've got is our GP queuing is now a lot longer, but our receptionist queue times have dropped to almost nothing. People are having calls answered quickly. People are having no problem with booking in at the beginning. People are also having no problem booking in their tests. So that 1 extra receptionist has made a massive difference. I'm also going to go through and just show you a quick way actually of running these different parameters. So changing this, what I'm going to do is I'm going to change that number of receptionists back to 1. So let's call this our sort of base example. What I'm also going to do is I'm going to go through and I'm going to comment out some of these print statements that we've got, because I don't want to print out all of the data frames right now, to be honest. I'm just interested in these averages. Those other ones were useful while we were trying to make sure that everything was working right. But for now, I am not going to print the trial results. I'm not going to print these bits of the trial results. I'm going to print this here. There we go. So, and if I now run the trial, you can see that all we get as an output, we shouldn't get so much, so yeah, we just see the trial results. So let's call this let's make a new markdown cell. I'm going to call this base case, and that will be what we started off with. Now I'm going to be a bit cheeky here. I'm going to do so I've got markdown cell, and I'm going to call this scenario 1, and I'm going to go to receptionists, please. And here, I don't want a markdown cell actually, I want a code cell. I'm going to do g dot number of receptionists equals 2. I'm then going to copy and paste this cell. And now when I run this, you can see that we've now got those much shorter times. The instances where we've got the receptionist queue times being much shorter, GP queue times being a bit longer. Why are the GP timers longer? Well, even though we didn't change the number of GPs, that's probably because people are going through that receptionist process so fast, they're now sitting around waiting for the GP. So previously there was a bit of a bottleneck, and actually the GP queue times didn't look too bad. Well, that's because everyone was still waiting to see the receptionist, so it was sort of moderating that flow before it got to the GPs. But actually that still suggests that maybe actually the GP time is a problem. Let's try scenario 2. This time we're going to have, let's stick with 1 receptionist and, oh, reception, I don't think that, can I spell? And 3 GPs. So let's see actually what happens in that situation. So I'm going to set my number of receptionists back to 1. I'm going to do g dot number of GPs back. I'm going to set that to 3, and let's see what happens here. And I would expect this to be worse. Let's see if that matches my intuition. So yeah, now we've still got those sort of 60 minutes of time across the different situations. So we've got 60 minutes for our receptionist queues. We've got very short GP queue times now, but that's still not a great situation to be in this case. What else could we do? So we could do scenario 3, and here I'm going to do, what am I going to do? Let's go back to 1 receptionist, 2 GPs, and what do we want? We want a shorter time for booking in. I think let's pretend actually that we are going to have an almost can we have basically an automated system? What happens if effectively we change the sample time, the average time it takes to be? No, I don't think we can do that through our G class. I was thinking if we could set the activity time for being signed in to an average of 0, but I think we'd still then get some people coming through with that step of being required. I don't think we can change much more here without, we could make it so that the mean call time's a bit faster, but that seems unlikely. We could make it quicker to book the tests, maybe. Maybe there's a problem in the system at the moment that means they have to do quite a lot of manual steps. So we could have a look at that, but the other times seem unlikely that we're going to be able to shave much of that. So 1 receptionist, 2 GPs. I'm going to do so 1 receptionist, 2 GPs, and let's say quick test booking. So we're going to create our number of receptionists, number of GPs, and g dot what was it? Oh, I put this in a markdown cell, that's why it's not giving me any suggestions. So g dot test mean registration time, mean test booking time, and I'm going to change that to 2 minutes. Does that make much of a difference? Probably not, as we've only got 25% of people needing to book a test anyway. So it does make some difference actually. We've gone down from an average, so this is the same as our base case scenario effectively, gone down from an average of 59 minutes and 57 minutes for the answering calls, down to a better length of time of 45 minutes, but it's still long waits. Let's see, what else could we do? So this is where we need to start effectively changing our model. Now we could get all fancy here and actually start doing, if we could create a subclass, a child class of our model and start overwriting the methods. We're not going to do that for today. I'm just going to do a little bit of old-fashioned copying and pasting. So the first thing I'm going to try out is one of the scenarios that was suggested of making it so that the GPs are the ones booking the test. Let's see what happens if we do that. So class model, I'm just going to copy the model class for now. That's the only one I need to be overwriting in this particular case. I am going to have to copy the whole thing. Not the neatest and easiest way, but let's do that for now. So, well, it is probably the easiest, not the neatest. But what I'm going to do is I am just going to point my the test booking step. So where we've got this attend clinic, instead of requesting a receptionist, I'm going to request a GP. And all I'm going to do then is I'm going to make a note of what this actually is doing. So we're going to have GPs book tests. I'm going to run this class, run this cell to overwrite the model class with our new model class. And I'm going to make sure that we're back at the default, so we've got the mean number of tests, the test booking time is back at 4 minutes. We've got one receptionist, two GPs. Let's look at what happens here. And this time the average receptionist queue time is down to 33 minutes, but this has not done good things to our GP queue times. We're now at 55 minutes for those GP queue times. Still got quite a long time to actually book your test as well, and actually the time to answer the call is doing better, but overall this hasn't really solved our problem. I'm not going to go too much further with this, but just to let you know, you could basically play around with this now. You can keep copying the model class and making changes. I've also just realised I've been spelling receptionist wrong this whole time. But anyway, thankfully, due to the loveliness that is the autocomplete in VS Code, then that has not caused us any problems. Anyway, what I'm going to say is you could start doing something like you could create another class of resource. Maybe we have one receptionist who is dedicated to answering the phone lines and doing nothing else. Maybe we do want maybe we want to actually remove that step entirely. Maybe we're going to automate the booking in process. Maybe they've just got a screen. Maybe that's a sample one again. Maybe most people manage to log in fine, but maybe 1 in 10 need actually some human intervention from the receptionist still. So you could have a branching process there, a bit like we did with sampling whether people need to book a test or not. But for most people, maybe they bypass that step of needing to book in with a receptionist, and actually they go through a new automated terminal that we've put in and see how much difference that makes. So you've got lots of options now for seeing what is possible to do within the confines of this existing model that we now have that we can play around with. So have a bit of fun. Code for this will be available in the video description, but I hope that's helped you understand how we can build up these models quite iteratively and actually get to ourselves to a situation where we've got a model where we understand every single step of what we've done in it, and you can use this to create your own models of your own systems.